So good morning, everyone. My name is Mark Richardson and I'm the CEO of the National Biofouling Innovation Centre. And I'd like to welcome you here for the second in our series of three webinars covering the area of marine biofouling. And today's seminar is around the challenges and opportunities of antifouling biocide regulations and an industrial perspective. And this builds upon our last webinar, which really focused on the regulatory context. The agenda for today is shown here. I'll shortly be handing over to my colleague Keng-Meng Koo from Lonza Specialty Ingredients, and then we'll be having two speakers, Neil Oxtoby from AkzoNobel International Paints and Gareth Prowse from Hempel. And then towards the end, we will have a question and answer session. And we ask that during the webinar, if you would please put your questions in the Q&A box. You will see at the bottom of your screen a button that says Q&A. If you would type the questions in there, then during the session, we will be looking at those questions and pick a number of those, as many as we can, to be answered at the end by our presenters. Any who are unable to answer during the time we have, we will ask our presenters to kindly answer them after the meeting, and we will send all responses to those who posted them as soon as we can. And the video of this webinar will be available within a few days, and we will send you a link to that post-meeting. So without further ado, I wanted to hand over to Keng-Meng to introduce the rest of the session.
Thank you, Mark. Good morning, good afternoon, good evening to everyone, wherever you may be. Thank you for taking time to participate in today's webinar. My name is Keng-Meng Koo, and I'm the Head of Regulatory for Lonza Specialty Ingredients in Southeast Asia and the convener for the Singapore National Mirror Working Group for Antifouling and Ballast Water Treatment. We have worked closely with Prof. Stefan in the working group to conceptualize this webinar event, and we strongly support this splendid collaboration between Singapore and the UK to advance sharing of knowledge and ideas in the antifouling sector. So without much further ado, I'd like to introduce our first speaker, Neil Oxtoby from International Paint. Neil, the floor is yours.
Thank you, Keng-Meng. I'll just share my screen. Ooh. Hopefully that's working. Can everyone see it?
Not yet.
It's not loading yet.
Apologies.
Yeah.
Yep.
Thank you, Neil. Yes. Yes. So I'm going to start by briefly introducing myself and the company I work for. I'm then going to talk about biofouling and what that is, and specifically how antifouling coatings can help combat it. I'm then going to talk about regulations and then talk about product development and how that sort of fits in the context of those regulations and the issues. So I work for AkzoNobel. We're a major supplier of marine and yacht coatings. So on the left of this slide, you can see a ship, a vessel, and then on the right there's a yacht. And our company split the market in that sort of way. So we split the pleasure craft market from the commercial vessels. And a lot of the regulators take a similar view, and they'll split up the regulations and legislation between the two. You can see the international brand on the bottom of that yacht on the right. And so that is a brand name that's been around for a long time and is part of the AkzoNobel group of brands. And that might be more familiar to some of you. As an industry and as a company, we do move ahead of legislation and regulation. So we're not just driven by that, we are trying to move ahead of that. We are proactively trying to eliminate materials that are hazardous and take a sensible view of the world. So as I said, I work in the marine and the yacht part. We're actually the marine protective and yacht part. So we coat anything that comes in contact with the sea. So you've got ships, but there's oil structures, they have fouling as well, and yachts and things like that. So there's the brand names here that you may have heard of. And there's the R&D global footprint. So I'm based in Felling in the north of the UK, but it really is part of a global team. So I've got colleagues that I collaborate with in Singapore, in Korea, China, America, and you can see we've got a spread of labs globally here that are trying to develop products for our global customers. And we've got quite a few more manufacturing locations. So if we're to include manufacturing locations in that, there'd be a lot more on the map. So we're trying to develop solutions globally for our customers, wherever they are in the world. And they'll have different challenges and different needs and different requirements. So if I talk briefly about what biofouling is, so this is the unwanted organisms on immersed structures. So there's quite a few, there's 5 images, and there's quite a range there from hard animal fouling in the top left to slime in the bottom right. Marine architects spend a long time trying to come up with a nice shape for a vessel that makes the fuel use as minimal as possible. When you put those into the water, marine growth will start very quickly. So for those of you based in Singapore, it's very aggressive fouling challenge there, and then within a few days you will start to get things growing on a surface. In the cold North Sea, near where I am, there's less of a fouling challenge, and it'll take a bit longer. So there is a need for different products for different locations, different operating profiles, different customer demands. There's several thousand of these species, so there's probably 4,000 or 5,000 is the estimates that I've seen of different fouling species. And as these develop, they're increasing the drag of the vessel. So the big impact that has is that your fuel use increases significantly. And for a ship owner, that's a huge expense. This is the major cost for operating a vessel, is the fuel. For yachts as well, there's some maneuverability issues. So there's some safety concerns there about maneuverability if the yacht is heavily fouled like it is in the middle picture. So as the drag increases, you're increasing your fuel, and there are other issues that I'm going to talk about in a moment, but the best way to prevent this happening is to use a good anti-fouling coating. So by choosing the best anti-fouling coating, you can prevent this happening, and therefore prevent the issues that I'm going to talk about in the next few slides. That's not always easy to choose. There isn't one coating that works well and is the best coating for everyone. So it's important to try and choose the right coating for your vessel or for your yacht. And coating suppliers can help you with that choice. So as well as fuel, there's obviously other things that happen when you're burning fuel. So there's greenhouse gases. So greenhouse gases, if the global shipping industry was a country, IMO, so IMO is the UN body that represents the oceans. So it's part of the UN. So they estimated in 2014 that we'd be the equivalent of one of the top 10 countries in the world in terms of greenhouse gas emissions. And that is because a lot of things are moved by shipping. Most goods are moved around the world by shipping. They had 4 estimates in this 2014 study that CO2 emissions would grow between 50 and 250%, depending on various economic outputs and scenarios between 2014 and 2050. There's also an ambition to reduce the levels by 50%. So there's a mismatch there. There's a growth in greenhouse gas emissions and a desire to reduce them. And biofouling can have a big impact. It can add 40 or 50% to a vessel's whole emissions. So by using the right coatings and reducing the drag, you can reduce fuel and also then the associated greenhouse gases. There's some recent changes in the fuel landscape. So IMO again, this UN body of the sea, at the beginning of this year, they introduced a reduction. So there's been a sulfur limit on fuel use for a few years. I think from 2005 was the original global restriction. And that's been reduced from the beginning of this year. So this will have, so as they're saying there, 77% drop is their estimation. So it's going to have a big impact on human health, especially if you live near a port city or a coast. And it's also going to reduce acidification of the oceans and various other things. But one of the side effects of this for the shipping industry is that you need higher quality fuels in order to do this. So this is again pushing up your fuel costs so that your fuel will cost more. So again, there's an economic driver there for vessel owners to use a good anti-fouling to prevent the fouling. The alternative to a better fuel would be a scrubber, which would remove the sulfur before it's emitted, but that again is cost. Another issue with fouling is non-indigenous species. So on the map there, you can see pathways where non-Indigenous species are translocated from one location to another, where they can have a big impact on that local environment. There was a UN glow ballast project to eliminate this through ballast tanks. But more recently, if there's a paper in the bottom right, the focus seems to be more on holes, and that there's an estimation that over 50% of translocated species are moving on holes. And so you can imagine that big global vessels are moving these around from one continent to the other or one country to another, and then you can have small yachts that will move those within a country or within a region. There's a glow fouling project on the UN is aiming to reduce this and build capability to help stop the spread of these non-Indigenous species. I'm now going to move on to talk about some of the regulations associated with fouling. So on the right here, you can see a picture of the world and then the different impacts and emissions that fouling and coatings and vessel emissions can have. So there's yard emissions when the coating is applied. There's human exposure, so the applicators can have are obviously exposed to the coating there, and there's paint emissions in the bottom left, where these are the biocides coming out of the coating, for example. But there's also vessel emissions, so these are the greenhouse gases and the fuel that I talked about, and there's the invasive species. So all of these things are impacted by the coating choice and the fouling. And if you focus particularly on vessel emissions and the biocides being released, for example, there's a risk that vessel emissions and invasive species go up. So if you squeeze one part too much without considering the global impact, then the risk is that you have an unintended consequence. So the ultimate ambition should be to minimize the impact for the environment and humans, and that's through having maximized product performance. So by having products that work, efficacious products that prevent the fouling, that are also minimizing the emissions. Specifically for anti-foulings, there's quite a lot of regulation. So again, at an IMO level, a global level, there's the Global Anti-Fouling Convention, the Anti-Fouling Systems Convention. So this is sometimes referred to as the tin ban. This was used to ban TBT. More recently, that global convention, there's another biocide, sibutrin or ergorol, that is being proposed to be banned at a global level. COVID has delayed that, but that's likely to go through this year, and then with a time frame to follow in the next few years. There's regional regulations, so BPR and things like that at an EU level, and then there's a lot of national. There's Turkey BPR, KBPR, Australia and the US all have these. So regulations are rightly in place to ensure the responsible use of biocides. But there's different regulations. There's not just those regulations that impact on anti-foulings. So there's chemical legislation. This is things like REACH that are covering all chemicals used in all coatings. There's human protection. So this is at lots of different points. So this is application, removal, things like dermal contact with the coating. And then there's environmental protection. So this often focuses on what comes out of a coating, but there's also those greenhouse gases and NIS impacts that should be considered. So anti-fouling coatings sit in the middle, and I've shown them overlapping, but they don't always overlap. So sometimes the legislation and regulations don't always work in the same way. And there's a danger that they don't have harmonious regulatory landscape. A slightly different sort of regulation is the biofouling regulation. So this relates to the amount of fouling that's on the vessel. So this relates to how good a product you have, the amount of fouling that's on your vessel. So there are some countries that are now looking at how much fouling is on your vessel, how clean it is. And as I talked about earlier on, the best way to prevent fouling is to have a good coating system. So there's California and New Zealand, and there's Australia has a Biosecurity Act, and they don't have formal regulations yet, but they're on the cusp, I think, of having those. So there's some regions where, as a ship owner, it's important to have a clean hull, as well as having other things. So in summary, there's a lot of regulation and legislation, but you need this to work in a harmonious way that works together. You could imagine that if you had overly conservative modeling, so some of the regulations are based around modeling, and if these are overly conservative and take something that's beyond a realistic view of the world, there's a danger that you may unnecessarily remove products from the market. If that happens, then you're reducing availability of effective products, and potentially, in an extreme case, all the effective products in a particular market. And that will lead to increases in greenhouse gases and NIS. Also, the shipping industry is a global industry. It operates across borders and regions, and so having misaligned national and regional regulations may be ineffective. If a ship owner cannot get the coatings they want in one region, it's possible that they will go and get applications in a different region. And we've got a changing landscape with these products. So that a changing landscape should stimulate innovation. But unfortunately, there's also a lot of uncertainty. And it's that uncertainty that's hindering the innovation, I think, in this area. So if I move on to product development. Product development can take a long time. So at the bottom of the screen, I've got sort of the movement from a lab through to some field testing, through to application. And that can take several years. If there's a new biocide, a new active involved, there might be a step before that where the manufacturer of that is also then involved in doing their development of their active and their biocide. And it takes longer if you want to produce a new technology. So if you're doing something quite different, using a new biocide, a new delivery mechanism, a new way of preventing fouling, that's all likely to add to the timeline. There's also no one size fits all. There's no product that works for all vessels in all scenarios. So there's a range of products and technologies that are needed for our customers. So there's been legislation and regulation for a while, but this hasn't ceased the development of new products. So there are new products still being developed. So there's a couple on the right from my company, but there's a range across the industry. So new products continue to be developed. And I think customers are better placed than ever to really understand the performance of an antifouling. So there's ISO 1930, which is an ISO standard allowing customers to look at the fuel they are using and link that to hull performance. So they're then able to understand, is the hull performance they're getting and their fuel use, is that really down to the antifouling choice? And understand and measure and maybe justify internally the choices they're making in their antifouling. So that's very data driven and fuel and sensors, but there's also drones that allow visual inspection. So it's a lot easier than it's ever been to have a look at what is on your hull. Is there any fouling? Is your coating system working? There are a small number of biocides that are available. So I think the focus is going to be on making the optimum use of this available toolbox. It's possible that new biocides will come onto the market, but there's a huge cost. This was mentioned a couple of weeks ago in the first webinar. There's a big cost, a big barrier to entry for a new biocide. So it's not impossible, but I don't see a huge number at all coming. So I think the focus will be on making the optimum use. And I also think there's a trend for more collaboration. So as I talked about at the beginning, I'm part of a global team within my company, but there's also a lot of work with universities and suppliers and third parties. So I don't think anyone has all the answers anymore and can do things in isolation. On product registration, this can lead to a phased launch. So you could be getting some products in some regions faster than others just because of the process of registering a product. So until now, I've talked about biocidal products, and there are other options. Biocidal products dominate the market. But for some customers, there are effective non-biocidal fouling control options. So fouling release has been on the market for over 20 years. And for some customers, this is a better option. It gives them less fuel use, less drag, less invasive species, all of those things. So it doesn't work for all customers. But there are some areas of the market where there are some non-biocidal options. And then there's alternative technologies. So as I talked about collaboration, so AkzoNobel are working with Philips to look at an alternative solution. So we're looking at UVC. So this is used to prevent fouling in different scenarios, and it does work in a marine environment. So this is a tile here. This is where there was UV that was preventing the fouling that's grown around it. So there are other options, but as I talked about with product development, this is a more different technology. So this is using tiles effectively to tile a hole, and therefore your product development timeline becomes longer. Thank you.
Thank you, Neil, for an excellent presentation. And it's my pleasure now to introduce our second speaker, Gareth Prowse from Hempel. The floor is yours, Gareth.
Thank you, Keng. I'll just share my screen now. If someone could confirm they can see that for me.
Yep.
Okay, good. And hopefully you can all hear me clearly. So my name's Gareth Prowse. I work for Hempel Coatings. We're a manufacturer of protective marine yacht coatings, wind blade coatings, wind tower coatings, very similar to AkzoNobel and International, as Neil's just introduced. We have a global footprint and supply companies globally and have R&D globally that pretty much the same as Neil's described. So I won't go into too much detail on that. What I wanted to do is to build on what Neil has presented and zoom in on some of the issues that Neil's laid out and put that in the context of what our customers, the ship owners, are trying to achieve in terms of managing their compliance requirements with invasive species and also greenhouse gas emissions, but also to try to show you how these different solutions might fit in solving those solutions and meeting the challenges so that you can see the opportunities and where they come from. Ultimately, the legislation we see is all about protecting the environment. So I want to explore where the focus is in terms of the environmental agenda and lay out the relevance of biocidal coatings within that framework and what the challenges are. As a disclaimer, I don't have time to go into everything in detail, as you might expect. The focus is obviously on coatings. As another disclaimer, my background is not in chemistry. I'm notionally an ecologist. My studies were in marine biology and a PhD in ecology. So my perspective is slightly different. I've been involved with regulatory affairs for about 15 years now, and I'm currently part of the commercial organization trying to encourage our customers to use more sustainable solutions for the future. So we're following this initiative very closely about greenhouse gas emissions. And for us, there are three main concerns that our customers face and what we're working to help them with. One is reducing greenhouse gas emissions. The second is invasive species management. And then the third part that catches us out, as Neil's pointed out in the Venn diagram, if you like, is the environmental emissions, which affects us as producers of coatings, but also our customers in terms of what comes off the vessel. But currently the main focus is on one, the greenhouse gas emissions. And what's important to note is that how these each of these three parts are regulated has an impact on what you can do with the other two. So this refers back to Neil's toolbox discussion, if you like, about biocides being limited to us now. But identifying how you harmonize your technology or your approach across those three is key in what the future looks like and what we can offer to the market. So if we go into a bit more detail on greenhouse gas emissions, if I can get my slides to work, sorry. We see that the biggest focus now on IMO is to decarbonize by 2050, as Neil's pointed out. So we've got initiatives in clean fuels, retrofitting equipment to vessels to improve efficiency, and then ultimately novel vessel design, which are various designs now drafted, getting ready to be produced and built in the future to give us these decarbonization process by 2050. The efficient vessel design, which is seen as the sexy stuff or the heavy engineering where everybody focuses on these discussions, that introduction of these designs is very slow, and we'll touch on why that is in the future slides. Retrofitting of new equipment is generally costly, but we're going to see some changes there as IMO bring in the revised EEDI rules, the Energy Efficiency Design Index rules, which will move things forward in terms of what vessels have to achieve. And major improvements need to be put in place very quickly because the lifespan of a vessel is very long. So if you don't have stuff in place by 2025, you're never going to hit the 2050 targets because the vessels won't be renewed because the owner wants to keep them in operation for the longest period of time possible. So in that regard, hull efficiency remains critical, irrespective of the solution adopted. Less fuel equals less emission, plus a sustainable use of resources. There's always a cost in terms of carbon release. Sometimes at the stack emission if you're using fuel there, but if you're using clean energy like ammonia and hydrogen, you've got a production aspect to that too. So the sustainable use of things is very important to achieve these CO2 emissions reduction. The solutions are being used right now. The survey of vessels built in 2013 to 2017 showed that lots of vessels were actually complying with the IMO interim target 2025 to reduce emissions by 30% right now. So 70% of containers, 26% of oil tankers. So it looks like we're making good progress, but when you look at the actual numbers involved in that cohort of vessels, actually we're making big progress in small areas. Where we need to get things moving is on bulk carriers, where there are lots of vessels out there, but progress to efficiency is actually quite low. So only 1% of bulk carriers carrying these devices or improvements to pick up their efficacy. And also when you look at the fourth IMO greenhouse gas report, we can see that we're not hitting the targets now. So total greenhouse gas increased by 10%. There was an increase in methane by 150% as vessels started to convert to LNG, and demand grew twice as fast as efficiency improved. So there's a big increase in efficiency need across the fleet, and coatings can provide a real solution here, particularly biocidal ones. So if we look at how we're going to mitigate these greenhouse gas and invasive species emissions, the key is on hull efficiency, as Neil's alluded to earlier. Irrespective of the vessel design, it can be the most efficient vessel, but if you can't keep a smooth hull and a propeller, then you're never going to achieve the efficiency of the vessel that you want. So there are two aspects to look at in this. One is the absolute hull smoothness out of dock. So this is on the y-axis, where your line, your fuel consumption starts with the perfect hull form. And then the second aspect is a decrease in that performance with time as the hull becomes more rough. And that is associated with fouling on the vessel as you move through time in service. So between getting recoats. And the current approaches in the markets address those issues, particularly for coatings, but the adoption of best practice across the fleet varies massively by vessel type. So we know that choosing a coating system affects hull roughness and then fuel use and the penalty of fouling. Silicone systems are known to give a 6% improvement out of dock in terms of fuel. So just converting from a standard SBC or antifouling gives you an increase in efficiency. We know with our own silicone coatings, you can see that microscopically, but we also know that the application techniques can improve that further still. So if you've got a clean hull to start with and you control the application very carefully, and you can do that by robotic application or industrial application to films, and then applying that to the vessel as a finished coating, gives you an even smoother coating system. So once applied, the coating plays an active part in maintaining efficiency. It stays smoother or gets smoother with time in a polishing coating system. It minimizes fouling buildup, and a hull free of invasive species is a smooth hull with good fuel consumption profile and no invasive species potentially. So there's a win-win there. If you solve one issue, then you solve the other. And right now, biocidal coatings are the dominant choice to prevent fouling. But as Neil mentioned, coatings are not all born equal. Getting the right product for the right job is important. You see big differences in performance from one coating to another when you choose and select for the vessel. Not only that, what you see is a very big difference in the amount of biocide that you use. So in these images, we can see a 0 biocide fouling release working very well, compared with a standard SPC product, which isn't working too well either, with high biocide loading. We see extremely good performance with fouling defense coating, which is a silicone-based system using low-level biocide to give you extra performance. And then you can see comparisons between those fouling defense coatings and silane methacrylate, but you can also see big differences between the ablative coatings and the SPCs. So product selection is really important. High performance can be achieved with low biocide levels, but what we don't see is the best product always being used in the right circumstances, which means more frequently now we see a shift towards cleaning of vessels. And there are two types. One is proactive grooming. You clean before the fouling gets to the extent that there's a penalty, or there's reactive cleaning where you know it's got quite bad, so then you go in for a clean. And these require good data and information about when to clean. There's a trigger there. But once you do the cleaning, you're either maintaining the performance of the coating or boosting the performance if the fouling challenge changes. So if you need to change the route of your vessel, it could be correcting the coating failure, or it could be maintaining compliance with those Australian rules. I need a clean hull to enter your port. This is how I do it. I can clean, and then that proves that it's free of invasive species. But cleaning isn't always an easy option. So you still have an emission aspect to this. Certain ports don't want you to clean in their waters because they have concerns about emission, either paint flakes or biocide removed too quick, or the invasive species themselves. There's a lack of availability. You can't clean in every location you want, and a time constraint to that affects what the vessel can do. He doesn't want to delay while he's doing his clean. The final comment from a coatings perspective is that if a coating isn't optimized for cleaning, you can damage it, and then that will drastically affect how well it performs. So both of these approaches are sound, but they need to be applied properly with a good understanding of the challenges ahead for that clean and where you're going to clean, which is a complexity that the customer isn't always prepared to take. Which takes me into the environmental emissions. So what does this mean from an emission perspective? How do these solutions align with the need to reduce environmental impacts? And can we move away from biocidal or chemical approaches to fouling control? So this is really the challenge to us as scientists, academics, and industrial actors in this field. The next big thing that we see is the legislation that Neil mentioned. Chemical emission laws are restricting the use of products that we sell right now. Invasive species control is driving the need for better products. So you have a conflict there for promoting biocidal products or more toxic products to give more kills, so cleaner hulls, etc., versus something which is trying to balance the use of those chemicals so you don't cause adverse effects in the environment or to the people that use them. Ultimately, though, we're moving toward a zero emission future. No biocide release, no chemical release, no species release. And biocides right now are critical for the industry, and the transition for that will be challenging. There's no doubt that the current technical solutions give clear benefits. So when you look at what the tools are available to owners right now, we can see that there are various ways to make a more efficient vessel. Coating solutions are part of that. And we can see that advanced hull coatings, really good ones that perform well, can give you up to 10% reduction in fuel and energy efficiency. And that compares directly with some of these more expensive engineering controls like wind assistance and hull form optimization and so on, and propeller changes. So it's clear that coating solutions give genuine benefits. But not only that, the return on investment is typically really quick, so that you get your money back for the fuel saving very fast compared to putting in a big engineering control. And they're retrofitted very easily. So you get improved efficiency with low technical costs. Everybody can apply a coating. We're used to doing it. So working within that as a solution gives us a big opportunity to make a significant contribution to CO2 reduction. And the efficiency right now is on par with the more expensive options. So ultimately, a smooth, fouling-free hull is still a key area for performance going forward, and that's not going to change. Another study, Green Ship of the Future, looked at some of those solutions and tried to assign how much saving you would get on a typical vessel. And what we saw with Hempel's Hempel coating, a silicone-based system, is that actually you get the largest CO2 saving with the shortest return on investment of any other option you can put out there. So whether it's a Flettner rotor or a propeller change. So it really does support the fact that there is space and there will be a continued need for effective coating solutions and hull coatings that are easy to apply. And right now, it appears that the most efficient solution is biocidal coatings or effective biocide-free coatings where they're appropriate. So there's a big potential for coatings to contribute to this reduction. They're easy to install, as I mentioned, and they're cost effective. However, getting a best-in-class product is difficult. the owner doesn't always take the best product for his vessel. The majority of the tonnage is cost conscious. Convincing companies to take new or better products is challenging. So changing behavior in the industry can be quite difficult. And there's a perception in some areas of the fleet where an aging fleet isn't worth investing in. It's a wasting asset, it's getting old, it's going to be scrapped. So why should I spend money on expensive products to give me fuel performance? And a lot of that comes from that you've got this complex environment of different people with different objectives in managing and running a vessel. So that is a huge challenge to bringing new things to market. On top of that, you've got a yard focus, which is on productivity, how quickly they can get a vessel out. And the application and installation process is a significant barrier to introducing new concepts sometimes. Industry infrastructure pivots around airless spraying of wet paint. It's fast, efficient, effective. So when you try to use films or robotic application, that's an additional barrier to get a new efficient system into place. So it's not always about the biocide use or the coating technology, sometimes it's the application. So the real opportunity in the interim is whether we can move this whilst we wait for this. So what can we do with biocides or coating solutions or other easy to fit options while we're waiting for these grand designs to come through the system and process? And whilst we're doing that, we need to think about what zero release could look like so we can stay ahead of those legislations. Right. So Neil's pointed out the UV LEDs, they're very effective, they work really well, but you've got an installation issue there. We see lots of activity with ultrasounds and they can work very effectively. But the jury's out on how many vessels that works for and whether it's sufficiently good for all vessels, whether it would be a real solution for a zero emission system. Next generation foul release coatings, Neil's already alluded to the fact that they're out there right now and they do very well. I'm sure the technology will continue to improve and they'll take a much larger proportion in the market going forward. But there's still an issue around the application side of things where yards don't like to use silicone-based systems because of contamination concerns. So does that take us into textured surfaces as a potential option for things? So there's still plenty of scope for room to move these things. A final comment on that would be, I'm really interested in biocides in the terms of minimizing their release, so tether them into a solution so they do they're active at the surface, but they're not released into the wider environment. So we need to think more broadly than we're just going to lose biocides. Can we be smarter in the way that we use them? The coatings industry has been very good at that. You see a general reduction in the amount of biocide that we've used over the past 20 years even, as we become smarter with the resin technology we use to deliver the biocides. So I think we'll be moving in that direction further still over the next 5 to 10 years. So some final thoughts. It's all about managing the transition. So there will be a role for biocidal products in the near future, but we will need to do less with more. Neil mentioned losing the toolbox. That's very true. We're losing existing biocides. And there are very few new biocides being put forward because the regulatory hurdles to bring something to market is extremely high. So we're looking at trying to do more with less. Whatever we use and whatever we go forward has to be more sustainable. There's never been more pressure on reducing chemical emissions, plastics in the environment, the perception of circular economy and how we make that work for coatings and all the rest of it. We really do need to focus on the sustainability aspects of what we take to market. So having these novel applications to prevent release will play a key part in my view on those things. So effective high performance biocidal products offer a fit and forget approach, which is extremely beneficial. So you paint the vessel, if it works really well, you send it out for its 5-year schedule life. If it doesn't need to clean, it doesn't need to come out of service, it just comes back clean, that's perfect. It's operational efficiency, cuts down on the wasted time, reduce the risk of emission from cleaning or from interventions elsewhere. And that's a really ideal situation for a coating. That's what we're all working towards. And that's what I mean when I talk about best available technology for each category. I think I've got a duplicate slide coming up here. So a fit and forget approach. So perhaps this is best seen in the interim as being holistic hull management. So total control in the future is going to be likely to be a mix of approaches, okay? So vessel design, fouling control, fouling management plan, scheduled cleaning, careful void solution, using big data and hull performance tools to identify when you need to intervene or to select a product or a solution or a series of solutions to do that. I think we're starting to see customers and operators think in these ways. And so it's going to be really interesting to see what they do with the existing fleet going forward over the next 5 to 10 years as they need to hit these new targets. And that's going to be critical, at least until we get a final silver bullet. And it's debatable whether we'll find that one-size-fits-all solution for underwater hull control. But it also means that sustainable use, we've got to be connecting the legislation. So it's not good enough just to control biocide emissions. We need to look at everything: dockyard emissions, cleaning emissions, resource production emissions, vessel emissions, and so on. So really taking a life cycle analysis to understand the cradle to grave assessment of these products. We can ban all the biocides, we can ban all the chemicals, we can have chemical-free solutions, I'm sure. But do we do that at the expense of higher greenhouse gas emissions, greater risk of invasive species being delivered, bigger environmental impacts from these other areas of production? So we really do need to think a lot more holistically in everything we do, the solutions, but also the life cycle impacts that we provide when we take these things to market. Thank you for your time. I will stop sharing.
Thank you, Gareth. Tom, would you like to take the question and answer session?
Yes, thank you very much, Keng-Meng. Will, are you going to ask the first question?
Sure, absolutely. Yes, so I'm Will Green from the National Biofouling Innovation Centre. And we're going to go through the questions that are in the Q&A box now. If you have any additional questions, put them in, and anything we don't have time to answer live, we will email around to everyone after the event. So if you think of anything in the last minute, please do submit it. So the first question we had come in came from Suresh, so thank you for that, Suresh. It was 3 in 1. So the first section, and this probably applies to both of you, Neil and Gareth. The biofouling regulations, are they mandatory or guideline in Australia and California?
Do you want me to take this, Neil?
I don't mind. Yeah, if you want to, Gareth, please.
Well, I mean, please go ahead.
I don't think they're mandatory in Australia. There's certainly some mandatory aspects in New Zealand, and biofouling guidelines are mandatory in California. I think in Australia that the legislation is all about a wider aspect, and they're probably going to introduce mandatory guidelines maybe later this year, but shortly, I think, is where we're at.
Yeah.
I don't know if Gareth has more information or a better view.
Yeah, I think that's a good analysis, Neil. The situation in Australia, they don't have a clear sort of country policy. So what you actually see is that what you need to do to comply is different from state to state. So it's a bit of a patchwork of how much scrutiny your vessel gets as it comes in. But what we do see is that there's a lot of collaboration between Australia and New Zealand and California, for example, that they're aligning on what they do with these state controls. So I think the next thing that will be interesting will be what happens in the US, because the Coast Guard and the federal government now is starting to look at how they can update their vessel general permit to something a bit more robust to cover invasive species. So in the next 5 to 10 years, we're definitely going to see a lot more structure around what vessel operators have to do before they can actually enter a port and deliver their goods. So it's a growing area rather than something that's going to calm down or disappear, that's for sure.
Thanks very much. And the second part of his question was, did the regulations make an attempt to differentiate invasive species from overall biofouling community? And if so, is there an economically feasible and user-friendly solution available to distinguish invasive species from local species in the fouling community on the whole?
Do you want me to take this, Neil, or you?
I'll give my answer, Gareth, and then you can agree or expand or disagree as appropriate. I think it's certainly in New Zealand, it's a percentage of the hull, but they also have a separate percent, so a percentage of the underwater hull that's covered by fouling, hard fouling. And I think they have a different percentage for niche areas, so you're allowed slightly more in niche areas. They're harder to access. So the niche areas are things like grills and inlets under the vessel. So these are harder to coat. They operate different hydrodynamics, so you may get more fouling in those areas. And at the moment, I don't think there is any differentiation between non-Indigenous species and Indigenous species within those percentages. And in terms of greenhouse gases and things, it doesn't matter. So ideally you wouldn't want any, because that's going to help with invasive species, but also with greenhouse gases and fuel use. So you can have a globally better solution is to have no fouling, no hard fouling, or if not none, try to minimize it as much as possible. I know there is some work looking at how you could distinguish invasive species, but I don't think there's an economically feasible and user-friendly solution at the moment. But that might be a route in the future. But ideally, you would want no fouling or no hard fouling, or minimizing that on your vessel.
Yeah, I think just to add to that, I think in Western Australia, they really had very strict rules at one point in time where they were doing a lot of ship surveying and inspections, and they were actually identifying invasive species because they were doing actually doing species identification on sampling on vessels. But I think that what they realized is that that's way too complicated and too difficult to do with the amount of vessels that are entering their waters that could represent a risk. So what you see now is a transition more towards risk-based evaluation. So the MARS system in Australia, for example, requires the vessel operator to put in a load of information about its route, when it last updated its anti-fouling, has it been cleaned, etc., etc. And off the back of that, they use some algorithms to decide whether they should invest more effort to go and see what's going on with that vessel. So is it high, low, or risk, high, medium, or low risk? So that's really the user-friendly solution. And predominantly what it's doing is to make a judgment as to, will there be fouling and where does it come from? So that you can begin to rule out the high-risk stuff. So in terms of economically feasible, those routes really are the only way you're going to be able to do this. So again, that really supports a kind of fit and forget approach, alongside of hull monitoring and evaluation of fuel use and ROV inspection or whatever, is to qualify, yeah, I've got a coating that works or a solution that works really well, and I can prove it because I've got all this monitoring that shows you that my hull is clean, so that the regulator doesn't have to waste loads of money or impound vessels to go and do all these inspections. But the final comment on that is there's kind of this academic discussion about whether a non-Indigenous species is invasive and whether you should worry anyway. And depending on the regulator, you get a different approach. So New Zealand is very strict. They say we just can't take the risk. Any non-Indigenous is potentially invasive, so we want a clean hull. Whereas others tend to be maybe a little bit more pragmatic. So I think it's an excellent question, and we're a long way away from having a sort of economically feasible and user-friendly way to make that analysis of what's going on the vessel. But right now, it's just trying to decide, is it free of fouling or not, as Neil mentioned.
Brilliant, thanks very much, and I hope that answers your question, Suresh. If I hand over to Tom for the next question.
Thank you, Will. My name is Tom Vance, and I run a coatings test house down in Plymouth in southwest of the UK. I'm really interested in the forms of these new technologies that we've been talking about today. Thank you very much, Gareth and Neil, for your talks today. They were spot on and really what we were hoping to achieve today. I'm going to start with a question that came in from Colin Anderson, and he's talking about, the question is, were there any unintended consequences of the IMO ban on the use of TBT? And would then the banning of current actives result in potentially those same unintended consequences? I'm going to start off with Neil, if you could give us a response to that, please, and then move on to Gareth in a minute.
So the TBT ban was before I joined the industry, so I don't have direct experience, but I can share, and maybe Colin, who asked the question, might have views, because I think he was in the industry at the time. I think it's all about effective products. So if you have effective solutions, my understanding is at the time there were copper-based, the sort of biocides we have now, copper-based biocides, and they are effective for lots of vessels, lots of the time, if you deliver the performance. Certainly within our company, we see the current best products being as good as those TBT products. So I think if you can deliver effective performance, then you have less consequences by removing a biocide from the available pool, the available toolkit. So if you were to ban current actives, so that was the second part of the question, wasn't it? If you do ban one of the current actives, would that result in an unintended consequence? I think we've got quite a small toolbox now. So if you remove one of the co-biocides that helps give biocidal products a broad spectrum of activity. There's a big risk there that for those biocidal products, you're going to reduce the spectrum of activity, you're going to get some fouling. So I think that there aren't effective solutions for coatings for all vessel types at the moment. So I think there would be consequences that maybe didn't happen in 2003.
Brilliant. Okay, Neil, thanks very much. Gareth, you got much to add to that one?
Oh, I mean, it's a loaded question, really. I think the unintended consequence for me is that the industry had to shift in terms of how it demonstrated that products worked really well. So TBT was very effective for lots of good reasons, but it's definitely the case that the people that have been around in the TBT era had rose-tinted glasses towards those coatings. So there was a perception potentially that those coatings were way better than the new ones that came to market. And as Neil said, when you analyze data on the new coatings and compare it to TBT, actually what we sell now and have sold for a long time is every bit as good as the TBT coating. It's just in the transition between people getting used to the new technology, because by design it has to work differently to that type of system. You know, there were teething troubles as with every new product introduction, and that really is the challenge: is how you take a new product to market to give the customer the confidence and demonstrate that it's as good as what he's already working with. And sometimes the best product, it can be amazing, you can show it, but if they don't trust you and don't believe you, you're never going to make any progress. So I think for me, that's the unintended consequences, that to some extent you see a lot more cynicism against products and skepticism about how these work. And it put more pressure on the coatings industry to actually be able to demonstrate with credible data that these things worked. Because everybody just says, oh, well, it's never going to be as good as TBT. Why can't we just have TBT back? And that's a discussion that's been taken with a few people that I've spoken to over the years. So.
Okay. Yeah, thanks, Gareth. Right, I'll hand back to Will for the next question.
Sure. So next question came in from Andrea Castellin. And she asked if we could elaborate a bit more on the non-biocide options that you both spoke about during your talks. And just wanted to clarify, is this an opportunity because it respects the current regulations, including like the environmental protection and similar things, or because the non-biocide options has no regulation at all, and so you can kind of bypass?
So Gareth gave a nice summary of the broad scope of current non-biocidal options. And lots of those, if they're coatings, they're still covered by lots of legislation and regulation. But I think beyond that, it's the customers want effective products. They want a product that's going to minimize their fuel bill. So there's a direct and strong economic link there. So a non-biocidal option is not governed by biocidal legislation, because it doesn't have biocides in it. But the customers are still demanding efficacious products. They still want a product that's going to work. So I don't view it as a way to sidestep the regulations, because there's still a need to have very effective products. And I think that's to an extent why biocidal products are still dominant in the market. They've got a proven track record of being effective for lots of vessels. But I think there is an opportunity in the future. So if you can prove that a non-biocidal product is effective, so there are fouling release products that work for some vessel types, there may be other technologies, or as Gareth talked about, maybe it's more than one technology and you need a combination of things that will work in the future for other parts of the industry.
Yeah, and if I can just add to that, so is it an opportunity? Absolutely, it's an opportunity. But it really depends on the type of solution you're offering. So when you say it respects current regulations, environmental protection, etc., or is it non-biocide where there's no regulation at all? If you're selling a coating, it's not true to say just because it doesn't have a biocide, it's not regulated. So the moment you start to use chemicals to formulate a coating system, then you're under a different set of regulations that still focus on the environmental emission. Whereas if you're talking about UV and things like that, which is a more technical engineering control, the regulations are different, probably something to do with ship safety and things like that, and how you operate the vessel. But you still have to face some set of control that you can use to place it on the market and then demonstrate it works for the customer. But the big barrier to that is the really clever stuff requires a different way to fit it to the vessel. And right now, in my view, the next 5 years, the challenge is always going to be around, can you stick it on the side of the ship? And in some of the route, like the best performance, UV, for example, I love UV. I've been a big supporter of that for a long time. It's extremely good in terms of performance, but trying to get it to work on the side of a container vessel that's 400 meters long, that's going to take a lot of steps to get us there before we can do these things. So it all comes back to operating within the regulations that affect what you sell and being responsible in the way that you take those products to market from the environmental emission side of things. And that's why I talk about life cycle analysis and really understanding the impacts that a product has and using the tools that we have in chemical legislation for environmental risk assessment, human risk assessment, to make judgments over what you use and take to the market. So I think it's a little bit more subtle than just avoiding a regulation or complying with a regulation. It's about how you make the best use of the available tools that you have to you. Thanks.
Brilliant. Thanks very much. I'll hand over to Tom for our last question, and any additional questions we will answer offline. So please feel free to submit any more in the time we have left.
Thank you, Will. So there's a question from Serena Teo, who's come in and talking about niche areas and relating to the fact that non-Indigenous species are often found in niche areas on vessels, sea chests and propellers. And she's interested in your opinion of the speakers about how anti-fouling technologies have advanced for these areas and what are the major challenges for tackling that niche area fouling. So yeah, I'll start with Neil again first, please.
So yeah, so just in case some of the audience don't know what a niche area is, it's part of the vessel, it's not the main hull, it might be a grill or an insert, something that's taking water in for a cooling system, that sort of thing. So they're a relatively small percentage of the total area, but they've got quite a lot of complexity, and therefore they can often have a lot more fouling, which is, I suppose, the basis of the question. There are lots of options, coating options that provide solutions to these areas. So you can have a different coating, a different specification, one that will work better in those areas. So that's an option. I think the longer term option, which is what I've heard from some of the yard associations and marine architects, is maybe trying to minimize the number of niche areas and the complexity around them. So, but as sort of Gareth alluded to the talk, if you want to change the design of a ship, that's a long process that will take a long time. So you can do that with new vessels that you're designing, but you've obviously got the global fleet that's out there now with all of these niche areas. I think UV has a strong potential in niche areas. You could design an insert, and that's one of the things that is a potential route for that UV technology. I think one of the big challenges is at reapplication, so at dry dock, ensuring you get a good quality application. So it's maybe not just the coating, but it's ensuring you get a good quality application. So often these areas are welded shut, and so you have to unweld them, cut through them. So it's physical access that sometimes is the hardest part of ensuring a good quality application to give you the protection in those areas.
Brilliant. Thank you for that, Neil. I think, unfortunately, we pretty much hit our time limit here, so I think we'll have to call it there. I just want to say thank you very much to the speakers, Gareth and Neil. Thank you for your contribution today. Much appreciated. And I'm going to hand back to Mark to close the webinar today.
Thanks very much, Tom. And thank you all very much for attending today and giving such good attention to our speakers. And I'd particularly like to thank all our panelists, but in particular Gareth and Neil for their excellent presentations today. And I did just want to remind you of the third in our series of webinars on this subject matter, which is, as we were starting to talk about in that final piece of the questions and answers and the presentations, biofilm control, what's next? This will be on November the 9th, 9 AM UK and 5 PM Singapore time. And if you're interested and haven't already registered for that, then please contact either NBIC, SCELSE, or the Singapore National Biofilm Centre. So thank you again very much for your attention today. Any questions we've been unable to answer, they will be separately posted to you in terms of the answers. So thank you very much. Please enjoy the rest of the day, and we'll hopefully see you next time.